So recently we've done a lot of work on straight line graphs. We've done drawing them, we've done interpreting them, we've talked about gradients, y-intercepts, equations, tables, parallel, perpendicular, lots of things. But it's been a little bit disjointed because partly on the nature of online lessons, things get a bit disjointed. We've had an assessment in the middle on a different topic. We've had a couple of well-being days which have sort of broken the flow of teaching. So what today is a recap of everything that we have done so far to do with straight line graphs, an example of everything we've done, an example of questions and how to answer them. And then I'm going to give you a few questions to practice. They'll be fairly similar to the ones I'm doing, but it's just to make sure we can bring together everything we've done and not just let something slip through the crack. Okay, so first question I've got in front of me is draw the grid from -10 to 10 in the x and y directions, and then draw the graph 2x plus y equals 10. So first thing I'm going to do is I'm going to draw my grid. So -10 to 10. That means I'm going to have to do 20 squares down, 20 squares across. I'm only marking on every other number because otherwise things get cluttered, but I am doing a little line for every one. Here's 0 in the middle. So other direction. And this pen's running out. Right, one more. So I've got my grid. It's got 0 in the middle, goes up to 10, down to -10, across to 10, other way to -10. I've got one square representing 1. I've put little marks every 1 square, but you can see it's kind of cluttered already, especially with the minus signs. So I've only put on every other number. And the next thing I've got to do is draw the graph 2x plus y equals 10. So when we're drawing a graph, so I've got 2x plus y equals 10. I've got my little grid I've got to fill in, so x and y. And then I always pick 0, 1, and 2 for x, and I've got to figure out y. Now what I'd normally do is I would say, well, let's turn this into words and then do that to the x's to find out the y's. This one's slightly different because it looks different. It hasn't got y equals, which is how the other ones are, and which is why we were able to turn them into words. So I'm going to show you a little different strategy for ones which don't look like that. And we're just going to substitute in these values for x and find out what y has to be. So x is 0, and this is twice x. So twice x is 0 still. 0 plus something equals 10. Well, it's got to be 10, isn't it? So that means when x is 0, y is 10. And I do the same with 1 and 2. So x is 1. This is twice 1, which means this is 2. 2 plus something equals 10. It's got to be 8. And one more. This is x. This is twice x, which means it's going to be twice 2, 4, plus something, 10. It's got to be 6. Okay, so it's just about thinking about, well, let's put the x part in, and it's almost like filling the gaps. And there's nothing wrong with writing it out with a box in place of y, and that way you can figure out what y has to be for it to equal your answer. So I've got my grid. I'm going to turn that into coordinates. So my coordinates from there are going to be 0, 10, 1, 8, and 2, 6. And I'm going to plot those coordinates. So 0, 10, 1, 8, and 2, 6. So I've got my points, and now I join it up with the ruler. But I don't just join that up because that would be a teeny tiny line. I extend it the full length of the grid. So there's my line, extended the full length of the grid, and then I label it with the equation. So 2x plus y equals 10. And that is how to draw a grid and how to draw a straight line on it. Draw the grid, just be careful, plan it out, make sure there's enough space, put on the numbers and the little dashes to show where things are. Draw a little table, figure out, is it the sort of equation where I fill in the gaps, or is it the sort of equation where I turn it into words? Both work. You find out what goes in your table, you get to your coordinates, you plot your coordinates, you draw your line and you label it. So that's how to do that one. Let's have a look at another question. Okay, so this question is asking us, what is the gradient of this line? So I've got a line drawn out and I want to know the gradient of it. And how to actually do gradients is you pick a point on the line, so a nice sort of point, and you're looking to figure out how many up does it go for each one it goes across. So I'm going to pick here, and if I go 1 across, well, it's between 1 and 2 up, isn't it? So it's not very good. I'm going to draw it all the way across there because that's nicer, isn't it? So for 2 across, it goes 3 up. That means for each 1 across, so for each 2 across, it goes 3 up. So if we scale that down, that means for each 1 across, half as much, it's going to be going up 1.5. That means the gradient equals 1.5. So that's a tricky one because it wasn't a whole number. A lot of the times you can just go 1 across and it's a nice easy whole number up, and you could just say, okay, 1 across 2 up, or 1 across 3 up. But in this case it was 1 and a bit, so I carried it on a bit to figure it out. Right, sometimes you haven't got the lines and you want to figure out the gradient and the y-intercept. So in general, your equation of your line, y equals mx plus c. The m is your gradient. And the plus c is your y-intercept. So the bit in front of the x is your gradient, and the bit after the x, including the sign, is your y-intercept. So for my first one, the bit in front of the x is 3, so that means gradient 3. And my y-intercept is plus 2. Next one, my gradient. So the bit in front of the x is a minus 4. So my gradient is minus 4. And my y-intercept is plus 2. Right, next one, gradient. Now there's no number in front of this x, so people generally start to do it wrong here. They either say the gradient is x. That's wrong. We didn't include the x in these ones. The x isn't meant to be included. Or some people say the gradient is 0 because there's no number in front of the x. But what we've got to understand is the number in front of the x is how many x. And how many x have we got there? We've got 1x. And we just generally don't put in the 1. But when we come to writing the gradient is 1. My y-intercept is minus 3. So the sign is important. It was plus 2. It was plus 2. It's minus 3. Then for my next one, my gradient is going to be 1/3. There's no reason why a gradient has to be a whole number. It can be a whole positive number, a negative number. It can be 1. That's the tricky one there. It can be 1/3. There's nothing stopping it being a fraction. And my y-intercept, that is the bit after the x. Well, there's nothing after the x. And that means it's going to be 0. And I know I said when there was nothing there, it was 1. And then when there's nothing here, it's 0. So just to explain that, the bit in front of the x is how many x. I've got 1x. The bit after the x is how much are you adding on or taking away. I'm adding on nothing, which is why that's a 0. Okay, so let's have a look at another one. You might get asked a question, are these points on this line? And we could draw the line and have a look, but that seems like a lot of effort. So what we can actually do is look at it algebraically. If we remember that the first number is your x coordinate, and the second number here is your y coordinate, then you can see if these numbers work in this equation. So x is 10. So 1/2 of x, when x equals 10, 1/2 of x is going to be 5. Take away 2, that's 3, not 6. So that one is not on the line. But I can do the same with my other one. That's my x, and this is my y. And if I put in 3 for x, if the answer comes out as it's meant to for y, It's on the line. So when x equals 3, 1/2 of x, so 1/2 of 3, so 1.5. Take away 2, that's minus 0.5. It is what it says it is. So B is on the line. So you can just check algebraically. You just got to remember that x and y coordinates are the numbers we put in. And if you just put in the x and see what the answer is, rather than trying to put both in, because that gets confusing. Okay, next. What is the equation of this line? So I had a look at the line before and I figured out what the gradient was. Now I want to know what the equation is. So remember, in general, your equation for a straight line is y equals mx plus c, where that is your gradient. And that is your y-intercept. And now I can just look at my line and figure out those bits and pieces. So my gradient, that's my steepness, 1 across, 2 up. That means my gradient is 2. And my y-intercept is where it crosses the y-axis. This is my y-axis. There it crosses it at -4. So if I put these numbers into this sort of format, I'm going to get y, the y and the x are always just y and x, equals, instead of m, I know the gradient is 2, so 2x plus c is just whatever this y-intercept is. So the y-intercept is -4. And there's my equation of my line. Okay, let's have a look at something else. So parallel and perpendicular lines. Now, we have to remember parallel, same gradient. Same direction. Perpendicular means at right angles. And as far as the gradient goes, it's going to be different sign, and one's going to be a fraction. So you're going to get, for a perpendicular line, one positive, one negative in the pair, and one of them is going to be a fraction and the other one's just going to be the number. And for parallel, it's the same gradient. And remember, the gradient is the number in front of the x. So if we just have a look at our gradients, this one is 3, this one is a third, this one is -2, this one is a third, this one is a half, and this one is 2. So parallel, same gradient. B and D. They've both got a gradient of a third. So parallel is B and D. Right, perpendicular. Different signs. So I need one to be positive and one to be negative. And I need one to be a fraction and one to be the whole number. So let's have a look. It's tempting to say A and B, because it's 3 and a third. One's a whole number and one's a fraction. But they're not different sign, they're both positive. So I can't pair A with B, I can't pair A with D, and these numbers are different with the 2s, so A is not going to pair with anything. B, 1/3, same thing. I've already paired B and D. Let's have a look. C, it's got -2, and E has got 1/2, and that fits because different sign, one positive, one negative, one's a whole number, one's a fraction. So C and E are your perpendicular ones. And let's just check. 2 doesn't pair with anything because it's got the different signs with C, but they're both whole numbers. They're not one a fraction, one a whole number. And they've got the one a fraction, one a whole number with E, but they're the same sign, so we haven't got that. So there's my pairs. Right, I'm going to look at an extension problem now. It's an extension problem because it's something we haven't looked at yet. It doesn't require any extra knowledge, but it perhaps requires a little bit of skill problem solving. So I'll work through this one, but it's called extension not because I only want some people to try it, not optional, but it's called extension just to let you know it's difficult. If you try this one and you don't get it, it's okay. So find a line which is parallel to y equals 2x and goes through the point 4, 12. So we've got parallel. That tells us that it's got the same gradient. So that means my line is going to be something like y equals mx plus c. But the gradient, it's going to be 2. So it's going to be y equals 2x plus c, some number. We don't know that. And the information I've been given is when we put 4 in for x, the y we get out is 12. So 2 lots of 4 make 8. What would we have to add on to make 12? It would be another 4. Plus 4. So the equation of my line is going to be y equals 2x plus 4. So let's just double check. Parallel to y equals 2x, yes, it's got the same gradient. It goes through this point. So if we put 4 in, 2 4s are 8, plus 4 makes 12. Yes, so that's that one. So I've got the questions, and I will be in chat to help if you get stuck.